Greetings, everybody. So this will be part 2 of my introductory video on parabolas and quadratic functions, and I want to lead up to what I'm going to show you now. What I've already told you is that a parabola is a shape. There's some details about that shape, such as whether it opens up or down. It looks like this. It's got a vertex at the bottom or the top. A parabola also has an equation. This form of the equation I've already talked about, and then there's this other form that I'm going to talk about now. Okay, so if I should see an equation like this, the graph of that is also a parabola. Okay, x and y are our variables in algebra, so I can, in that equation, plug in the x and get the y back out. In terms of graphs, there's an x-axis and a y-axis, right? So x and y is what we're constantly dealing with. And in this equation, a, b, and c are known numbers, okay? I'll show you some examples in a minute, and that and that and that are just going to be some number given in the problem, okay? Now, if I have an equation that looks like that, here are the details. First, it is a parabola. If you graph it, that's what it's going to look like. If a, this number multiplying the x squared, is positive, it opens up. If a, that number right there, is negative, it opens down. And then we calculate the vertex based on those numbers. Okay? All right, so let's talk about finding the vertex, because I think that's the part that, if you've never seen it, might be a little bit difficult. All right, so we find the x-coordinate and the y-coordinate separately. So the x-coordinate is negative b over 2a. And you find that first. You figure out this number, get it, whatever it is. And that's the x-coordinate. And then to get the y-coordinate, you plug in the x-coordinate into whatever the equation is, which will be this, okay? That's normally how x and y work out. If I know what x is supposed to be in any function, I can plug it in, do all the math, and get the y. That's the way it works. With a parabola and finding the vertex, I find the x-coordinate by that formula. I get it, figure out what it is, and then I plug it in to get the y-coordinate. All right? But we find them separately, one at a time. Now, let's talk about doing this in practice. I'll go over here and I'll do these few examples, okay? So here's one that is from my math lab. It says f of x equals negative x squared minus 2x plus 5. Real quick, does it matter if it says y or f of x? Not really. I mean, there's slight differences to it, right? When I write f of x, and I put f of a number right there, it just means I'm plugging that number in. It's just like shorthand, really. But other than that, like I've got it. There's like, this is negative 1. That negative right there is a number. It's negative 1 times x squared plus negative 2 times x plus 5. Okay, so like all those elements, those numbers are here, and it looks like this. It's a parabola, all right? It has a vertex, and so on and so forth. Now, all right, let's figure out what the vertex is. So I'm saying that A is negative 1, B is negative 2, and C is 5, okay? And then here were those formulas. To find the x-coordinate of the vertex, it's negative b over 2a. Okay, so now look, there's a couple of negatives happening all at once here. There's a negative included with this formula. It's negative, then b divided by 2a. Negative, then b divided by 2a. If b also happens to be negative, you got to include that too. So it's negative, b is negative 2 over 2 times a is negative 1. You see I plugged it in there? I got this negative that is part of the formula, and then I have this number which is also negative. I wrote them both down. And then I'll do the math from here. So let's see. There's not a whole lot of math to do, but 2 times negative 1 is negative 2. And then what happens if we divide -2 by -2, like right here. What number is that? That's 1. So it's -1. Okay, and so that's my x-coordinate. The x-coordinate of the vertex, let's write our answer down. I'm going to put the vertex in there. If I was on my math lab, it would be -1, and that'd be the x-coordinate. And then the y-coordinate, I haven't figured out yet, but it goes in that where that question mark is. Okay, how do you find the y-coordinate? Well, think about how equations work. If you ever know the x and you want the y, you plug the x in, and the y is what you get back out. So to find the y-coordinate, just take what you know x to be, which is -1, put it into that function, see what you get. So here I wrote the function with the black pen, -x squared minus 2x plus 5, and then I put what I'm plugging in, the -1, in red. Okay, then I do the math. -1 squared is 1, and I've got a negative in front of that. I got -2 times -1, that's 2, and then I got plus 5. -1 plus 2 plus 5 is 6. So my vertex, all right, I've got it now. It's going to be -1 is the x-coordinate, and 6 is the y-coordinate. It's a point. It can be graphed, right? Remember when in the first video I made, I showed you that don't forget the vertex is a point. You can graph it, you can get graph paper, you can put it where it needs to be, and then if needed, we could draw the rest of the parabola around that. Okay. Another thing I see about this one is that because of that number, does it open up or down? Let's see. I know this question doesn't ask that, but might as well talk about it because it will come up. So what did it say over here? If I have that form of the equation, whether the parabola opens up or down depends on that number in front of the x squared. If it's positive, it opens up. If it's negative, it opens down. So what I would see is that that would be the vertex point, and then it opens down from there. Okay, so this point is at the top right there. That's the highest point on the graph if you were to draw it. So if I could see it, if I could draw it, if I had graph paper, then I'd see this parabola shape, and then I'd see this point, -1 for x, 6 for y at the very top. All right. Okay. So let's look at one more with different numbers just so that we can explore all aspects of this. Find the coordinates of the vertex for the parabola. Okay. And I get that sort of equation. And again, you'd be going through in your head like, okay, is it like this one? It doesn't look like that. It doesn't look anything like this one. It's not this one. We're not going to analyze the problem I just showed you according to what it says here. It looks like this one. It's a number times x squared plus a number times x plus another number. That's what I see here. And in fact, if I were to read those numbers off of this equation, the way that is in my instructions, it'd be that a is 3, b is -18, and c is 1. Okay? All right, so let's find the x and y coordinate of the vertex. The formula is, what is it? It's -b over 2a, right? So I do negative, and the b is -18 over 2 times a is 3. So remember, I've got a negative that's built into the formula, and then I've got another one that's included with the number. All right, so I get like that. 2 times 3 is 6. -18 by 6 is -3. So I'm looking at, in the end, the opposite or negative of -3, which is 3. So the x-coordinate is 3. Okay, so my answer is going to be 3 for the x-coordinate and some number yet to be determined for the y-coordinate. I find the y-coordinate by plugging the known x-coordinate in. They go together. So there it is. And with the black ink, I put the function 3x squared minus 18x plus 1. And in red, I put the number I'm plugging in, which is 3. Okay, so I do all the math there. 3 squared is 9. 18 times 3 is 54. 3 times 20. So I get 27 minus 54 plus 1. That's negative 26. Okay. So I've got what I want. That y coordinate for the vertex is negative 26. And that's a point. That's something that I could graph. So on and so forth. All right. As far as just identifying the vertex, that's it though. All right. So now we've seen both equations that will come across in the class, and we know how to find the vertex of each kind according to these examples. From here, in the next video, we'll talk about how do you graph the whole thing. Here I made like a very sloppy graph where I just put the vertex of this down and wrote that it would open up, but the graph would have, if I was to really draw it, would have more details, more points on it, and it would look a lot nicer. But you get the idea. You see how we can get to that point, all starting with knowing how to look at the equation, tell whether it opens up or down, and figure out what the vertex is.